thanks everyone that is here in this room. It's a pleasure to be talking at this conference, and I really hope you will enjoy the knowledge that I brought here for you to share with you. So my name is Walmyr, and I work as a software engineer at appearin, and this talk is based on, sorry. It's not working. So this talk is based on a blog post I wrote in March this year called Lessons Learned So Far as a Software Engineer Working at appearin. At that time, I was working at appearin for 9 months. So now that I'm working there for more than a year, I will have a little bit more to share with you. So a little bit about appearin. I would like to, for you to raise your hands if you know about appearin. Who knows about appearin? 2 people? Cool. So appearin is basically a very easy to use video conference service that runs in the browser. And today we are trying to not focus only on video conference service, but also on letting people that use video conference services to do remote work and do remote meetings to have their meetings more efficient. So this is more or less our goal. And a little bit about me. So as I mentioned, my name is Walmyr. I'm from Brazil, but I live in Norway since June last year. I started living in Norway basically to join the appearin team. I'm a person that really likes to share knowledge in many different ways. So I have a blog, I have a YouTube channel, I have a book, and I really like sharing knowledge because I think this is how I think I learn more sharing than just reading or things like that. So let's go to what matters, to the lessons that I learned as a software engineer working in the team I work today. So the first lesson, automate everything you can benefit from. So at appearin, we have this mindset that automation can help us on building our service. So we use many different tools for doing automation in many different aspects, and one of them is ESLint. I think more than 90% of our stack is based on JavaScript, so many of the tools that I will show you here today are JavaScript based. So we use ESLint, that is basically for doing code syntax verifications in a totally automatic way. So you can be writing code for a new feature, let's say, and ESLint will be watching for what you are doing to check if the syntax or if the style guide that you defined with your team is in accordance to what is defined. And this is also executed in our continuous integration service as the first stage every time a pipeline is executed. We also use Mocha for unit testing, and we use Jest for unit testing of React components. We use Selenium together with Tape for running test automation for WebRTC, what we call WebRTC end-to-end testing. So for video conference service, you need to test that this real-time communication works, and we do this using these 2 tools integrated. We use Protractor to run UI functional testing. And we use Protractor integrated with Applitools for doing visual regression testing in a totally automated way. Then we use Terraform to create our infrastructure as code in an automated way as well. So we can scale up or down our infrastructure with just a command. And an example of using Terraform in an automatic way, for example, is that we have a schedule on our infrastructure on AWS, where, for example, for our continuous integration service that we use GoCD. GoCD basically uses a server and lots of different agents for running the jobs of the pipelines. And we have, for example, some GoCD agents running during the workday, and at night they are automatically destroyed, and during the other morning, new agents come up in a totally automated way because of Terraform. And finally, we use Slack bots for sending notifications to our Slack channels. So the point of all of these tools here is that you have advantage of using automation, not only if you use a tool isolated, but if you combine them. So for example, we have ESLint in our, so let's say I am creating a new feature. I submit a pull request, GoCD will trigger a pipeline that in the first stage will run the code syntax verification with ESLint. If this passes, a new stage will run unit testing. If this passes, then another stage will run WebRTC end-to-end testing, visual regression testing, functional testing. And let's say something goes wrong, a Slack bot will send a notification to our engineering channel on Slack, so we can act very rapidly to address this issue. Moving forward, the second lesson that I learned was so using linting rules to enforce best practices. So we as a team, we defined some good practices that we wanted to follow, and then we configured the tool that I mentioned, ESLint, to enforce that we are using this practice. And this is really helpful because in our software development lifecycle, we have a code review, and if you use linting, you don't need to care about when you are reviewing code of someone else if they are using the best practices that are defined by the team, because a tool is doing it for you automatically. And then you can focus on what really matters. So here is an example when you run this npm script here, when we defined some best practices that we want to use. For example, instead of using single quotes for strings, we use double quotes. We have indentation of 4 spaces instead of 2. And then when we run this script, it will basically find what is wrong with our code, and then we can fix it before submitting our pull request. And if we have submitted with these kind of issues, the pipeline will stop in the first stage, and then you have a quick feedback to fix it and move forward. Lesson 3, it's related to lesson 2, so it's about code review. And I mentioned that code review is a very good way to improve your coding skills. And I think on this sentence in 2 different ways, at least. The first one is that you can learn new coding skills by reviewing code of someone else that may have more experience than you in a specific technology, specific area of the service. And then you can, by reading the code of someone else, learn new things that you could apply when you are writing your code. And the other way that you can think about it is when you write code, you submit a pull request, and you get comments on your pull request of someone that is reviewing your code that can be a valuable feedback for you to improve for next iterations. So let's say I am not using a very good architecture for a specific problem that I'm trying to solve. Someone is giving me feedback on this, and then next time I have a similar issue to solve, I will remember that feedback and I will use it, and then I will improve, basically. So Every time you create a pull request, at appearin, code review is required. And you can only merge your code to master as soon as all tests have passed and code review is approved at least by one engineer. So lesson 4, run experiments. It's a bit related to the last talk about prototyping. So at appearin, we do many kinds of different experimentations, I would say. So one thing that we do is A/B testing. So we do A/B testing to see, let's say we want to solve an issue or we just want to develop a new feature. We want to see which of the versions of this new solution performs better to then work on this and then see who is the winner to put this new feature in production for all of our users. So an example of A/B testing we did, for example, for logging in at appearin, you need to provide or your email or your phone number. And we did an experiment of running as first option email and as B testing the phone number. Then email was the winner, and then we use email as a first option for logging in just because we collected data and we saw that this specific option was performing better for users than the other one. So it's a way to experiment and improve. We use a feature toggle so we can turn on and off features to users. This is something that is really nice because at appearin, you can have your own appearin room. So we can turn on a specific new feature for a specific room or for a specific user or for a range of users, or let's say for a percentage of our user base. So let's say we have a new feature. We don't think it's still very mature, but we want to test with real users to collect feedback. So we turn it on just for 1% of our user base, then we collect feedback, we improve, we iterate, and then we increase this percentage, let's say for 10%. And when it's very mature, then we can turn it on to everyone. Another thing that we do is feature flags directly in the URL. So for creating a room for doing a video conversation with someone at appearin, you basically type in your browser appear.in/the room name you want, and you send the link to someone else, and that's it. You join in a conversation. And we have many features that we are still developing that we can add a question mark, the name of the feature. This is like a feature flag that we can test things internally because we are users of our own service. So we can test things before these things go live. Then we can iterate, improve for then putting it on live. And other kind of experiments that we do is about experimenting technologies. So at some point in time, we decided that we wanted to have visual regression testing running as a part of our development process. And we did something similar to what was mentioned in the previous session about prototyping. We did 1 week of experimenting this tool called Visual Review, that is an open source library that you can use for doing visual regression testing. And we failed in this experimentation. But the good thing is that we learned a lot. The point when I say that we failed is that it was not a good fit for our needs using this tool. So we learned, and then we decided to move on to try to find another tool that would be a good fit for our needs. So these are different kind of experiments that we run. Lesson 5 is about learning and applying new technologies. So at my team, we are very encouraged to experiment and learn new technologies and apply these technologies when they make sense to make us move faster or just to add another layer of quality assurance verification, things like that. So some new technology that we learned and we applied. So in the beginning, when I started work at appearin, our front-end code base was basically Angular.js, but then we hired some new developers that were experienced with React, and by looking to this new technology, we noticed that we could move faster, we could create features much faster than using the version of Angular that we were using. And then we started learning about this new technology, and we started applying this new technology. So inside an appearin room, it's everything still Angular, but outside the appearin room, if you go to the login page, sign up page, and things like that, it's React. So this is something that we applied, and we are moving more things from Angular to React. Another thing is that we moved our code syntax from ES5 to ES6, basically because we wanted to have code more readable, easier to understand, easier to maintain, and things like that. And we knew that ES6 of JavaScript syntax was much better for this, so we decided to do it. And about the previous slide where we failed trying visual review, we found this tool called Applitools that is also for doing visual regression testing. And we learned about the technology, we applied it, we defined a strategy for using such tool, and then it was a good fit for our needs, so we started using it regularly. And now we have visual regression tests running every night against a master branch to see if the application is broken or not in a visual way, because the functionality can still be working, but it can be broken visually. So it's in our pipeline. And we already got some good feedbacks by using this tool. Sometimes we found issues, visual issues, before putting these new things in production. So the next lesson, lesson 6, is about interoperability tests. This is something that is very specific to our use case, but it can be applied to other use cases if you do, for example, real-time communication services. So for testing appearin, we have to do something like this. So it's not just testing that it works in one browser, because people will connect one person in one browser, another person in another browser, and they will have a conversation, right? So by doing interoperability testing, we have to test that different supported browsers will be working when you join a room at appearin. And this is just an example with 2 clients, but it can be with more clients, and we run such tests in our pipelines. And more importantly, we test, with this kind of tests, we test that our service works with, let's say, Chrome stable and Firefox stable, right? But we also test that our service will work with beta versions of browsers or even unstable versions of browsers. And if they fail, we know that, well, a beta version of Chrome today will become a stable version in the future, right? So we can prevent bugs that are still happening in a beta version to be deployed to our users when these versions become stable. Lesson 7, we use infrastructure as code. So as I mentioned in one of the first slides, we use Terraform, and we use to get Terraform together with AWS. So basically, we have all our infrastructure is code. The good thing about doing infrastructure as code, and this is something that's really interesting, because in my previous job, I heard a lot about doing so, but I have never done it. And when starting work at appearin, everything was code. And it's really different when you just hear about and when you use such thing. One very good thing about doing infrastructure as code is that you are changing something in your infrastructure and someone else is reviewing your code as any other part of the application. If something goes wrong, you can revert, you can roll back to a previous version of your infrastructure that was working. If you're having too much traffic in your service, it's really easy to scale it up just with code. And it's also much less prone to error if you do it as code than if you do it by a user interface, for example. Lesson 8 is that we work on small things. This is something that I really learned because in my first 2 weeks working at appearin in June last year, I worked for 2 weeks in the same pull request. At the end of the second week, I had lots of conflicts to solve, and I spent, I think, 2 more days just to solve the conflicts to then have my code merged. So by working on small things, first thing, we avoid conflicts because it's something that I will work today. I will get a review from my code from reviewers, and I will fix anything that is missing, and it will go forward. And by doing so, I have quick feedback during code review because for someone reviewing my code, it's much easier to review, let's say, 100 lines of code if you compare to 1,000, right? And then you can deliver frequently, and then you can show results to your product managers, product owners, and much more important to your users. And by working on small things, we can fail very fast, and we learn, and then we iterate, and we improve. So this is about working on small things. Lesson 9, this is the one that I like most. It's that we do refactoring without mercy. So at appearin, we are very encouraged to improve our code every day. So we do refactoring, and then we improve our code. We make our code readable, because when developing something, you, as developers, may know that you spend much more time reading code than writing it, right? So if you care about the people that will work on the same code that you are working today, you have to improve the code, you have to make it readable, so then when they are going to work on this code, they will understand what this code does, and then they can move faster. So by doing so, we make maintainability easier, and all of this is because we care of our teammates. So it's exactly what I was saying. I write code in a readable way because I know that someone else is going to read my code tomorrow. And the same in the other way. I want other engineers working with me to refactor their code to make it readable so that I can understand easily what this piece of code does, so then I can write more code on it. And one thing that I do regarding refactoring is that I take 1 day of my week, for example, for refactoring. So let's say every Friday, instead of developing new features, sometimes we have some technical debts because of some pressure. We need to deliver something to the users in a time that you will not be able to write the best code. But then I take 1 day just for refactoring, for cleaning it up, because I want to have sustainable code. I don't want just to deploy it and never look it back. And the last lesson that I learned at appearin is about creating pipelines as code. So as I mentioned, we do everything with code. So instead of doing things that may go wrong if you do by the user interface, we do it by code. So at GoCD, you can write pipelines as code using this plugin that in the beginning You had to install this plugin at GoCD, but today it's part of the core of the product. And basically for writing a pipeline, you do something like this. You define a pipeline, the name of the pipeline, you define the group of the pipeline. For example, we have pipelines for pull requests, it's a group. Pipelines for merge to master, for deployments. We have these periodic pipelines that are executed just for monitoring the service. Then you define the materials. In this case, it's basically a GitHub repository in the master branch. Then you start defining the stages of your pipeline. In this case, there is just one stage called deploy that needs manual approval, that has a job, that basically executes a shell script. And if you look to it, it's much easier to create a new pipeline if you have a template that you can copy and paste to create a new one where you have like different stage, different jobs. Also, you can have your code being reviewed by someone else. We run YAML lint verifications to check that the syntax is correct. If you do something wrong, you can revert. And that's basically it. So to summarize, we automate everything we can benefit from. So ES linting, unit testing, many kinds of different testing. And the point here is that don't use automation isolated. Integrate things. Integrate like a pipeline that will trigger different kind of automation and that will, for example, send notifications on Slack or inside your pull request on GitHub or whatever tool you use. Use linting rules to enforce best practices. If you don't use this approach, the first thing that I would recommend is like meet up with your team, define what are the best practices that you as a team want to follow, and then configure a tool for running this verification automatically for you. Code review is a good way to improve coding skills. So the two things that I mentioned, you can improve your coding skills by reading code of someone else or by receiving feedback of someone else when you are writing code. Run experiments, A/B testing, feature toggle, feature flags. Learn and apply new technologies. So it's very related to prototyping. Care about interoperability tests. So it's about preventing that versions of browsers that are unstable or beta will not break your service when they become stable. Use infrastructure as code. One of the best advantages of doing so is that it's very easy to revert a change if you break something in production. Work on small things. Refactor without mercy. Take one day of your week, one day of your month, what is reasonable for you to make your code cleaner, more understandable, more performatic, whatever. And if you work with continuous integration and with pipelines, try to find a way to create pipelines as code so that you can have your code, your pipeline code reviewed, you can revert things, and you can create new pipelines much faster. So it's a quick talk. I would like to thank you, everyone, and I have probably space for questions. And I have 2 shirts for the first 2 questions.
Nice motivation.
Any questions? Yes?
I didn't have a question, but
Oh.
a t-shirt. No, I do have. For linting, do you use auto-fixing? Or just, the annoying part where it breaks your build, for example?
So far, we just break our build. But actually, in one specific project, we are also doing this auto-fixing already more as an experiment. And so far, it's working really well. So we are probably going to start applying this to other projects.
And one more question. Do you Do you integrate linter into ID VS Code or whichever you're using?
Yeah, every developer in our team can decide which IDE they will use. So if you use an IDE where you can install a plugin for doing so, you're free to do it.
And you?
Yeah, I do it.
Okay, thanks.
If you can come here for your shirt. There was another question in here.
You mentioned that you are working with master branch after pull request. Your code is going to master branch. There's future and master branch in your case in daily work.
If I understood your question, you mean if we run the same things before merging things to master? Is it right?
No, no, no. You are working only with master?
No, no, no. We have, for all pull requests we create, we have a feature branch that is created, and then we submit a pull request. Then a pipeline is executed, where everything will be executed.
And this goes to production after
then, let's say every linting verification passed, every test passed, and code review is approved, then it's merged to master. Then everything is executed, not everything. Some things are executed again, like functional testing and visual regression testing. And then if these all pass, then this code can be deployed to production by any of the engineers in the team. And we do more than one deployments in productions every day.
Okay, thank
you. No more shirts.
Thanks for great talk.
Thank you.
I'm always interested in failures. Were there anything that you've tried and it didn't prove to be worth doing?
Yeah. So one case is what I mentioned regarding visual review. The main point was that with visual review, even when tests pass, you need to go there and, or at least the way we try to use, you need to go there and to approve that it's still working. And also when it fails, it was not breaking our build. So because you have to, with visual review, when it finds a visual difference, you have to go there and say, all right, so I will not accept this failure, and then you have to fix the bug. But with the tool that we decided to use, it just fails the build. So this is one example. I don't know if this answers your question. Yeah.
Maybe addition to this question would be, you showed stack of technologies or tools which you're using now. So how long it took to build this list, and maybe from this list is some failures what you tried but it didn't work at all?
So we try to experiment as fast as possible, to fail as fast as possible. So for example, for GoCD, that is our continuous integration and continuous delivery tool, in the beginning we used to use Jenkins, and we used the older version of Jenkins. No one was interested in upgrading to a newer version, and I already had experience with GoCD. So I think it took more or less 6 months to migrate everything from Jenkins to GoCD. But the way we did was that we started migrating things that were not too risky in the beginning from Jenkins to GoCD. This is just an example. And then when we saw that it was working, we started to migrate more things. So it took 6 months to migrate everything, but in the meantime, we had things working in both places. So it depends. Yeah, for doing the migration for the ES5 to ES6 syntax, it took much less time than this, mainly because we configured linting to check for ES6 syntax than ES5. Then it's basically reading the logs and fixing things. and you can do it even in some automatics way. So it depends on what things you apply, but for visual regression testing, it was like 1 week of work.
And talking about migrations, are you planning to fully migrate to React platform?
I'm not sure exactly, but we are seeing lots of advantages of using such tool. So I don't know if we will just migrate everything to React or not. But what I can say is that we are having lots of advantages of using such tools, so it's really possible.
Can you name those advantages?
Yeah, so yeah, one advantage I would say, because of we were using the older version of AngularJS, it was slowing down our software development, and with React we can just develop things much faster. Because of the concept of creating components, you can decouple much more your application. This is one of the biggest advantages that I see.
No t-shirts, but maybe more questions.
Hi, I would like to ask, for your WebRTC translations, do you use like peer-to-peer translation or some centralized server to stream it?
Yeah, in our service, if you use it in the free version, it's all peer-to-peer. But November last year, we launched the premium version. And in the premium version, it works with a server in the middle of the peers. And right now, we are working in, we realized that sometimes doing peer-to-peer is even better than doing a server in the middle. Because if you have a small group of people in the room, like let's say 2 or 3 people, it works better with peer-to-peer than with a server in the middle. So what we are doing now for the premium version of appearin is that we will have this thing that we call normal mode, room mode, and group mode. So if you are 2 or 3 people in the room, you are still on peer-to-peer. If another person joins, then a prompt will show up saying that you could turn to group mode, and then a server would come to send the streamings to all the clients. And then it improves a lot the quality for everyone.
Are you using Node.js for streaming purposes?
Yes, Node.js.
Is it work stable?
So we are doing many things for trying to make it as stable as we can. So sometimes because of not very good internet that our users have, it may become not very stable, but some things that we are doing for trying to make it better is like doing things like sending different, we identify the bandwidth of the different clients, right? And then if, let's say, you have bad connection and I have good connection, I will receive streams with better quality than you, or depending on the size of your frame. If you're in a small frame, I can send you less quality because it's small. If you if you supersize the video, then I will start sending you better quality. So this is one thing that we are working on. And we are working also on sending like 3 different quality of streams at the same time, and then selecting which one I will send to different clients in the conversation.
Cool, thank you.
You're welcome.
More questions? Then I have last one. You talked about code reviewing. So do you have rules, for example, that senior developers can review it and confirm, or anybody from the team, even junior ones, can do it?
Anyone is able to review any code, but what we do usually is like, so I am working on a specific feature that I know that someone else is very experienced with this. I will ask this person to review my code. And if this person wants someone else to review the code as well, this person will just comment with the user of this person on GitHub, and this other person will come to review as well. So this is more or less the way we do. And sometimes we also do pair programming, and then it's even easier to review because it's like while you are coding, there is already someone reviewing. It's not something that we practice a lot, but sometimes. But yeah, basically what we do is like if I am writing code, I prefer to ask someone that has more experience in that part of the code to review my code. Yeah, it's not the case in our. I really like to think that you have to reduce the work in progress so that people will have time for doing such things. Sometimes it takes a longer time for people to review the code, and this happens most of the times when a pull request has too much lines of code. So this is why we prefer to work on small things. And even when we need to work on bigger things, sometimes we split this in like 2 or 3 different pull requests. But usually we don't have this problem of no one will review my code. Like it may take 1 day, but someone will take a look at it.